Hi, you're welcome to my teaching on analyzing and detecting fake news and the real news. Today, I'm going to be looking at the data sets and I'm going to clean it. I'm going to actually do or train the data set and use these data sets to actually test and look at how accurate the outcome is going to be. But first of all, we have to look at what are we going to look at today? We're going to look at the news that is going around. I know this thing started mostly during the last political war between uh, the politicians about fake news. And actually, this has actually shed light to several things that have been going around, and people's life have been impacted by this. And it's going to be a good thing if we can actually detect it before the news actually goes out. So they said in the interconnected world, we see all these social media platforms, the news or the new, they're out there, they just put out news just to sell them stuff. So from here, from the introduction, we're going to actually look at what are the ways we actually go to, what are the tools that we're going to use. The first one is we're going to use the NLP, which is called natural language processing. And we're going to use also the deep learning models. This has actually performed well in several researches, and the outcome has been good. So first of all, what uh, what I did was actually looking at this data. How can we know that the data that we can how can we identify? But what happens is the articles and the news have been taken, and they are labeled, because once it's labeled, then you know. But there's no way for us to know. We can actually always dig into the source. So we're always going to know. We don't know which one is right, which is wrong. But at first, we take the data, we clean it, identify which is our label and our target. Our label, we say, is the independent variable, which actually we don't know. And the dependent is what we know. We know the news out there. Those are the tests where we have several headlines. But today we are going to be working with our test and labels, which is actually going to be what the test label is going to, which is real and which is fake. So first of all, what I did was set these labels and give them numerical values for the process to be able to work. So we label the real news, we label them 1, and the fake news, we label them 0. So after this is labeled, then our model can actually identify that, okay, this is what I'm working with. Then we train with these models, with these features. Then when we train with these features, we're able to now use this in subsequent predictions. So now, one of the things that was like we process the data, and this is by they start with cleaning. We clean the data, like unwanted elements are being taken out. The features that are not needed, like in the data set that I use in this program, we don't need the ID, we don't need the title of the articles or the news that are out there. So we took it out. So we stick with the text, and the level which we are going to use to train our model. So once we look at the features, we look at what are the null values. The null values are actually values that are not representative of what we actually need. They can be NA, none. So this is actually not good. So we're going to look at them. And when we look at it, we look at it, what are the numbers? If we should take this out, will it impact our model? So, but on this model, I looked at this and there was a null value. So actually, after drawing a chart, I saw that the null value actually came from the title. We are not going to use the title in our modeling. So, but I set the null to a blank state just to work with my to continue with my process. So the title and the ID on the data set was taken out. Then I did a word cloud to show what are the words that are frequent in the data set. We see our former President Donald Trump, we see the White House, we see several words that were represented. So in this, there's also what we call stemming, which will convert the words to the original root form. Like we say running, we convert it back to run. Books, we convert it back to book. So we saw that all this, we are all working at an equal level. There's no, we don't, there's the level of bias is being reduced. And also, in pre-processing, we vectorize the text because the model we're trying to use does not recognize all the letters. Computer don't recognize letters. So we'll convert all this to numerical values. And these are weighted. So after this process is done, we split the data. So we split the data to train and test. But before, we actually ask ourselves, is this data, how effective is it going to be? So, but all this has been checked and narrowed down. So we have to look at it, okay, are we going to get false information? So all this, what we are doing right now is to make sure that our data set is good so that we can actually prevent against all these things going on, misinformation and several things that are out there. They still, you see about COVID, several things has gone on that has made people haven't feel that, oh, they have COVID, and so many of these things. So just to guide against all this. So what are the rationale for our study? We are studying to create, we are doing this study to create models to be able to detect falsehood. We use this label, both like we said earlier. The labels are real and fake news. We assign values to this. And the model we use will check the effectiveness of the model. So the methodology that we use during this project, which is data collection and preprocessing. Modeling. The models that we use are LR means logistic regression, and our support vector machine, decision tree, random forest, and LSTM. LSTM is the neural network. So all the logistic regression, SVM, and natural language processing models that we use, and we use this classification model, decision tree, and random forest. And LSTM, which we said earlier, is a neural network model. So after we've actually run our data set through on this model, we evaluate them. we use confusion matrix and classification. Confusion matrix actually identified that it looks at the level of precision. It looks at precision and it looks at how precise are our guess. Whenever the models, because this is actually looking at this and assuming how precise is it? How is it fact or fake? Is it real or we just so that's how the confusion matrix is going to tell you is it really confused or is it actually getting a real report? And our classification report also is kind of there to get our position, but there's also what we call the call. Are we actually working on the actual right data or we just so all these are evaluations and the model comparison, we're going to compare accuracy score. We use consumer which has been said and class report which has been said. And also how can we improve our model? So this could be done through pre-trained words called word embedded. Early stop word embedded. There's this pre-trained word embedded that actually was released in Stanford Global 100D. So this is also one of the things to improve our models to make sure that okay, are we actually setting the right tone for the test and for the words? Early stop means whenever our model is running. The moment you see that our evaluation the accuracy is going low, it's going to stop. That's what we call early stopping. And then we'll present our report. So when we're looking at the accuracy of our model, we look at different charts. We look at how as our model, the moment you see a flat line, like, oh, okay, you kind of have an eight. That is this actually, can this actually work? So, but this is what we got from our tree classifiers, which is the decision tree and random forest. And like our confusion matrix, we said earlier, we see this is to see that on a real situation, is it actually real or is it fake? But we see that the percentage is really high over here. So we can consider it as factual. But when we see our predicted here, we're predicting that this is fake. But is it actually fake? This is actually fake. Is it actually real? Is we see this is prediction that oh it's fake. It's 90. The actual is actually real. Well, we see that we are not the confusion is not actual because see this actual fake is actually so it's really high. So we can actually accept this report. This is the one for yeah. This is still one of the NLP legacy regression. So we'll see, like I said earlier, we'll see that this is actually working well. So after looking at our data, we look at it that the accuracy is high on the three models. And you look at why is it that high? That is where we kind of feed it. So then we'll start, that's what we use, that's what we have to come back to this. Now if we should want to go further into this report, we see for the three models, the accuracy, the precision on this is actually way off. So we accept logistic regression, support vector machine. We accept this before tree models, which is decision tree and random forest. So it's a contribution to the body of knowledge. We are actually doing this to be able to enlighten people, enlighten them in looking at what is actually going on, what has this thing caused in in the life of people and being them, telling them to beware of what the action of fakeness in the life of people. Thank you.